Hello, welcome to Arcteq Webinar Wednesday. Today's topic is arc protection for low voltage applications. Kindly use chat tool if you have any questions, and I will be here to answer you. My name is Mikko Manninen, and I'm Arc Flash Product Manager at Arcteq Relays. First, a couple of real-life examples from low-voltage arc faults. First accident happened few years ago. There was a forgotten tool from after electricians left the building, and then there was a commissioning engineer doing installation test. Everything was good. However, after circuit breaker was closed, the tool accidentally dropped on top of the bus bars. Good luck that there was arc flash protection, and it saved the day that time. Another example is quite maybe a couple years back, and that was with a very heavy rated arc flash rated switchboard, and that was equipped with withdrawable starters. Starter was withdrawn, and the test engineer went to do some testing. While he accidentally touched with the live connector with a thin wire, and the other end of the wire hit the door. That case was more dramatical because the transformer was actually very close. It was like a half a meter away, and the backup protection was 450 milliseconds. So there was no good enough fast protection. But it was with arc flash protection, and that was also very good result. Some changes after some mechanical changes after that, but no human damages, no injuries. Low voltage board faults are often underestimated. It is probably people are more scared of medium voltage or high voltage boards, that there is a high voltage, so it sounds more scary. But low voltage is actually equipped with a very high fault current. If we have a low voltage, we may have very high fault currents, even up to 100 kiloamps or even higher. The trend is actually to build higher current boards, nowadays up to 100 kiloamps and even higher. Also, nominal currents are getting closer to 10,000 amps. Most typical high volume level is around 32 kiloamps to 65 kiloamps, and nominal current is about 5,000. So we can say that arc protection with low voltage boards is very important extra protection and safety. Low voltage, high current. Typical low voltage applications are main, tie main, or main tie main. This means that if we have main, we have only one main breaker. If we have main, we have double breakers. And main tie main means that there are two main breakers and tie breaker between. And that we could say that there is a bus A and bus B, left side and right side. Arc flash protections are typically installed in switchgears, MCCs, drive panels, and enclosures, and are often used in several different types of industries, like oil industry, paper, steel, car industries, maritime industries, food industries, etc. are often seen also hospitals, bigger supermarkets, nowadays more and more with data centers. Data centers are actually probably the most growing business area because of the digitalization and a lot of data centers buildings, office buildings and assembly factories. Sometimes also used within underground substations like subway networks. Underground substations are quite often very limited space for the pressure and exhaust channels. If there is arc fault, it is very difficult to get the pressure outside from the small confined space. Then also power plants, from nuclear to wind, from marine to land, all over. There are several standards for the arc flash protection, and these standards are pushing arc flash protection towards switchgear manufacturers. The most new one is IEC TS 63107, which was launched April 2020. And then several others like IEC 6094791, which is the arc quenching standard. So all these standards has been launched very recently, and it gives more knowledge to people to consider arc flash protection also with the low voltage panels. Other standards, for example here, the very global standards NFPA 70E and IEEE 1584, which are seen as de facto global standards, are giving the hazard risk category levels, and arc flash protection can lower the level of the risk to the better rating. Okay, arc flash protection, new devices which has been built with the purpose to be able to protect low voltage boards. These units, we say it AQ100 series, low voltage units, are divided with the point sensor type and the fiber sensor type. These units are also divided with current sensing elements and no current. And then some type of the point sensor units can be also ordered with the DIN rail mounted versions. As an example, from the top left corner, there is a AQ1010 unit. P means point sensor unit, LV means low voltage. And this unit has 3 current inputs, and it can be equipped with 12 point sensors. All these units can be equipped together with a reusable arc quenching device called AQ1000. That is the only reusable, resettable equipment in the world. It is a 690 rated voltage. It is a unique patented design, and operation time, total time is less than 4 milliseconds. From the actual fault to total 0 voltage. Operating time according standards is less than 2 milliseconds, and this is the mechanical closing time. This unit has a full self-supervision and it is type tested. Other products which can be used together with this LV, AQ-100LV series is AQ01 point sensor, arc light sensor, and this sensor can be ordered with the different sensitivity levels starting from 8,000 lux up to 50,000 lux. With one channel, maximum 3 sensors can be wired in series. Another sensor type is AQ02 light and pressure sensor. This is fully identical with AQ01. Exception is that this one has actually also the pressure element, and it can pick up from light and pressure, and typically these are used in the cabinets where current measuring is not possible, typically incomer cable end. Other sensor types are fiber loop sensors up to 40 meters. There are glass type sensor, and then there are plastic sensor types. And often with low voltage, fiber sensor is used, for example, bus bar, and sometimes even as a single sensor to the full panel. If there is a switchboard which has only one main breaker, then the location is not that relevant. It's good to know that if there's arc flash, we can then open the breaker, but the location is not that important. And the fiber sensor can be used in this case. I have an example here with the this is a low voltage example. It's called main time main, and this has now point sensor units 110 PLV in the middle, AQ1000 as a sequencer unit, and then 101 point sensors at the very left and very right. And this gives an example. I will explain it in this way, that the red ones are closed circuit breakers, the green one is open. So in this case, this is one of the most popular ways to build a switchboard main time main. Now the left side and the right side main breakers are closed, tie breaker is open. And if we have flash here at the very left side, what will happen? AQ110 PLV will measure current, and same time the left side 101 will send the light information to the 110 PLV. And that will immediately close the sequencer left side and open the breaker also from left side. And this sequencing will take less than 4 milliseconds, and then this breaker opening will take the breaker delay plus about 7 milliseconds for the opening. But because of this sequencing unit, the voltage will drop down to 0 immediately, and then the arc flash will disappear. Another example is that if the tie breaker is closed and the left side main breaker is closed, and there is a fault in the right hand side, Same unit will measure overcurrent, and the light information will be shared between units. And in this case, what will happen? We have a current and we have a light. Quenching will happen in same about 4 milliseconds, and immediately after that, the breaker will open. Tie breaker and main breaker will open. So this is the main idea of this low voltage arc flash application, and how the quenchers can be arranged. Then something very new. AQ103, designed for low voltage applications. This is something very new which will be available Q4 2020. So this is one part of the low voltage family, and the design difference, biggest design difference is that this unit will have 14 individual sensor channels. 14 individual sensor channels, and in this case we can then know the actual location of the fault better. The unit is also equipped with Modbus communication and can be connected, for example, the alarm and indication relay S254. S254 can be configured freely, and this is very nice that the fault location can be visually seen. This is very unique feature, and the location can be seen from the display. Okay, that there was a fault in the cable end, and sometimes when quenching device is working correctly and the circuit breakers are opening correctly, it is very, very difficult to find the actual location. And this could be one answer for that, to give the detailed location, what happened, when it happened, and how can the panel, what can be do that the panel can get live again. Also on the right side, it's the same S254 combined alarm annunciator display with timestamps, and this can tell also. Left side you can see it from the display very visually, and the right side will tell then the timestamp, what happened in the text form. And this is all available then Q4 2020. Product installation. Mainly 100 series is built with the flush mounted type relays. So this means that most typically these are built on switchboard doors, secondary compartment doors, and also retrofitting. Factory made is more easier, but also retrofitting is very easy to approach by drilling the correct size hole and then with the 2 screws or 4 screws tightening to the correct torque. And all the dimensions here are millimeters, so it's 162 millimeters depth and so on. The sensor installation methods, for example, here is one example of the bracket, how the sensor can be installed. In this case, this is a bus bar location, and important with the installation of the sensor is that if there are always some insulation levels, that for example, you cannot put anything closer to bus bars than 10 centimeters, then that should always be respected. That the insulation level stays same even after retrofit. Another example here is that the sensor can be mounted both sides. It can be mounted outside of the panel or inside the panel. And here is the better picture for that. So it can be easily mounted from outside, looking inside the compartment, and inside, looking also inside the compartment. And in here, we need to keep in mind that the pressure sensor has to be always mounted inside the compartment. AQ1000 installation, it is quite important that the location is as close of the main breaker as possible, that the impedance of the copper is minimum as possible. And then there are two possible ways to connect directly to coppers, where the best location is. Sensor placing. It is important that the sensors can be tested, and even better if the sensors can be tested easily. Sensors should be able to replace if for some reason they are mechanically damaged. Sensor can be easily retrofit to existing switchgear. This happens every day. Placing the fiber sensor so that the low voltage switchgear can be transported in pieces to the site. And this is for the new builds. When factories are building low voltage panels, they are probably building something like 3 meter, maximum 3 meter for, I would say 3 meter transport splits. And in this case, the fiber sensor is very much more difficult to install. That you have to keep in mind that the fiber has to be rewired on site after the splits are connected. Because fiber sensor is always loop. Our fiber sensor is fully supervised, and that's why it is loop, that we can get the supervision signal back to the relay. Typical sensor placing in low voltage switchgears are bus ducts, bus bars, aux transformer, circuit breakers, and both point or fiber sensors are used. Here is one picture of the actual installation. It's quite nice picture because there is also this pressure sensor. So if we have a look on the top left corner, there is this AQ02 point sensor. And why is it there? You can see the CTs are just on top of that. But what happens if there is arc flash before the CTs? Then most probably there will be no current, no overcurrent, because the short circuit is above the current transformers. So that's why this pressure sensor has been used a lot in this kind of compartments where the flash can be before the CTs. Other option is to have more or far end current measuring before the transformer or before these connections. But this is also one good way to do it, to have the pressure sensor here and light sensors everywhere else. Here under the circuit breaker there is AQ1000 quenching unit. It's very close to circuit breaker and it is directly connected to the bus bars. And then this secondary compartment door do have this AQ1000LV relay, which is connected to the AQ1000, and it will also give trip commands to the circuit breaker. And the best thing is that this is very, very easy to commission, and also the installation is quite fast. Some examples from actual site also, that there is an example of the door mounting. There is an example of the point sensor installation, fiber installation and wiring, and the AQ1000 installation with commissioning switch. And this is important. This commissioning switch, which is mounted on the right side of the AQ1000, you can reset this AQ1000 up to 100 times and actually do the commissioning. This is only unit that you can actually do the commissioning and measure the busbar impedance 0. So with this commissioning switch, device can be used 100 times, and without, it can be used up to 4 times with 50 kiloamps and up to 2 times with 100 kiloamps. And after all, testing and commissioning, it is important to do all the testings and commissionings according site rules, according standards, and to make sure that everything is fully functioning and working fine. Then closing the enclosures, cabinets, and then leave the site with a happy face, job done. And after this, there will be one video which will show you this AQ1000, how it's installed, and it will also give some idea of the AQ10 sensors activity and AQ110 relays, how it works together with AQ1000. Thank you.
The AQ1000 arc quenching device, the latest protection innovation from Arcteq, the pioneer of arc flash protection. Active arc quenching is the most exciting new solution for improving personal safety, maximizing asset reliability, and minimizing downtime. The AQ1000 can be applied to protect any system with up to 100 kiloampere and 690 volt rated equipment. The arc quenching device is bolted to the bus bars in the most practical location, typically close to the main circuit breaker. The AQ1000 adds to the well-proven AQ100 arc flash protection system. The AQ100 system senses the arc and initiates rapid arc quenching sequence, creating a controlled low impedance path, transferring arc fault current to the quenching device. All this occurs in less than 4 milliseconds. Arcing faults often lead to catastrophic consequences. By maintaining the arc time in less than 4 milliseconds, the AQ1000 mitigates switchgear damages and minimizes the process downtime and may save human lives. The AQ1000 operation is based on patented and dependable Thompson coil technology. The bulletproof mechanism operating time is as little as 2 milliseconds. The use of Thompson coil technology makes the AQ1000 fully reusable and testable. The system can be conveniently reset after factory or site testing. Embedded electronics provide for full system self-supervision and operator status indications. The quenching device reusability and onboard supervision features raise the bar on system reliability to a new level, offering guaranteed peace of mind by the ultimate personal safety and return on investment in a single operation and plant lifetime. Less than 4 milliseconds arcing time keeps incident energy levels in less than 1.2 calories per centimeter squared, according to IEEE 1584. AQ1000 arc quenching device, tested and approved according to latest UL and IEC standards. Arcteq, the pioneer.